you see source code. Typically, it will come from the GitLab, and you would need to pass instructions to a Docker runtime using a Docker file. We'll go through how to write a Docker file and what are, how do you pass those instruction in a particular format. But the source code with those instruction will allow Docker to run and build. Use this term build because Docker, it is an official Docker term. So source code with Docker file actually builds an image. That is a template of what to do with your code. How would code run? What are the steps before it runs? Imagine an exe file. So exe file knows, does it need to connect to your database, or to go to internet, or to any third-party service. So exe is that file which knows what to do when you launch and double-click that exe. So similarly, image is what is an executable binary of a Docker. Then when you want to run that application and that exe, just double click it. So there's a command in Docker which says run this image, what you have built already. So it runs. So from a Docker file, you build an image and then you run that image once image is successfully built. And that process after running, that process is called container. So that's all. So you have defined what is your code, how to run your code, you build that, and now you're running as a process. So that's all. It will behave same on a dev computer or a CI server, continuous integration server. We'll dwell into that later on. Now, just like your code, any exe, you need to save whatever you have delivered. So ideally, in older days, you would push your code and commit your code to Git. Here, just like Git, you would push your built image, which is an executable binary, to a Docker repository. You can call it Docker repository, registry, or these days it is called Docker distribution. It is one and the same thing. So we'll use repository or registry or distribution as synonyms throughout this video. So you push the executable into a repository, and here, just like your code repository, you can name repository and have different versions on there. So this is the naming convention, all small letters, colon, and the version name. You can define your version, whatever your project or customer demands. So this is Acme v1.2. This is Acme same repository, different version. This is a different repository altogether. Example with version tagged as v2. So there are multiple ways or repository you can implement. So Docker as a community, as an application, as a runtime, provides a default registry in Docker Hub. So it is just like a GitHub. It is a public space where you push your image, which has all your code. Remember, it has all your code pushed to public, but ideally you wouldn't want to do that because it's public. So you can have your own private repository hosted for your organization or for your project team or for yourself. So if you do not mention any explicit repository, then by default all these build, run, and Docker push are actually connecting to Docker. We'll see what a private repository actually means, because Hashdin uses their own private repository, and throughout this HU you will be using a private repository hosted by Hashdin. So yeah, so build, run, push. Remember these commands. So just to help you visualize, we have not yet gone to hands-on yet, But just to help you visualize and to continue the story, these are basic commands of Docker, which you will be using through your assignment today, as well as throughout your Docker journey. So, as we said, you need to build, run, and push. Here is create image, which is build. Write a Docker file, use Docker build command to create an image on local machine or any build machine. So this is actually the command which would run Docker build. Tag it. Tag is essentially your name of the image. Uh, this is the build context, which is the folder in the repository where would you actually want this build to be created. Use this build command. Then you run and test this application with the exe on your local machine, right? So you run using Docker run command. This is just in relation to your assignment, which we'll do in few slides. So yeah, you Docker run your image, which you have created last time, and then you push your image. Now, while you're pushing this, you have to understand that you might be working with multiple services, multiple projects. So you actually tag an image to a domain, a repository, and then you push it. So you have to say to Docker that while pushing this image, which repository to push. So first you tag that image with a repository, and then you push that image to the same repository. Finally, if you are a second developer working in the same application or new developer working in the project, you will pull that image so that you can start from certain base. So the whole exe, the person who wants to run or continue working on that image would pull a Docker image. So this is the command for Docker pull. This pull is not mentioned in the previous diagram, but definitely when you have pushed the image and hosted somewhere, some new developer or a QA team member would want to test and run, and this is how you share by pushing, and then somebody else pulls an image. This is just a sample Docker image. Remember, we have this Docker file which gives instructions to Docker runtime on how to use the source code. Same way. So this whole set of instruction is a Docker file. So you mentioned that from what is that base Docker image? Remember we talked about Docker Hub hosting multiple base templates. So this is that base template. You say that I want to start my application from this base image, which is Python image, and the tag, the version is 3.7 Alpine. Now you don't need to worry about what does it mean and all that right now. But remember understand from as a command that you are pulling a base image from Docker Hub, because Docker file by default only understand Docker Hub as a default repository and pulls the base image from Docker Hub. Then you run this command. So if you were given a terminal, then you can run make directory and create this directory. So how do you instruct Docker to create a directory? This is run command. Now you specify which work directory. Work directory is where you will actually Docker. So you cd into a directory and then start working. So Docker will actually cd with work directory into this code as a folder, and then start executing all the subsequent steps. So then you run the copy. Copy is again an instruction to Docker runtime that copy my requirement.txt file. This file should exist from the folder where you actually run Docker build command. So requirement.txt should be copied to Docker's work directory, which is code. So imagine that the directory that you're working and Docker's current directory is different, right? So, and that is why that is called context directory. You are working on a certain directory, but Docker will work on its own directory. So context directory and work directory are two different concepts. And then Docker, you instructing Docker to run this command, pip install -r requirement.txt is more specific to Python. You don't need to be getting confused about that right now. Again, you copy everything from the current folder to code, and finally you run Python app. This is the command where Gunicon would run Python app. So this is just a sample. And now, if there is anybody who knows Docker, just a note for them: this is not a production ready. It has a lot of loophole, but it is the simplest set of instruction that we could muster up to explain the basic set of commands from Docker. Moving on to the right side. So what will it do? What will it do actually? Host OS is the machine where you're running. It may be a VM or a physical server or your own local machine. Now it goes to context directory, which you have mentioned while giving the Docker build command. So it has source code, it has Docker file. So this all instruction just copy paste directly to a file called Docker file, exact same string. Docker runtime understand this exact file name to be its instruction set. So do not change, give space, rename anything. Docker file is plain and simple Docker file. No extension, no .txt, no .pdf, no .json or YML, just Docker file without any extensions. This Docker ignore is slightly advanced concept, not exactly advanced, but at least you don't need to know right now. But if you are working in a junk directory, you can specify that from my current context directory, do not include these files as part of my Docker container. So you can ignore set of files. Then this whole instruction set is read by Docker engine, and the way Docker processes it, it runs first command. So first is your base layer. Let's say you have given Python 3.7 Alpine. So Docker runtime reads this, say, oh, it is from. So it goes to Docker Hub, pulls Python image with this tag, and create a local temporary read-only image on your machine where you're running this. It then move on to the next one. It says run make directory and folder name is code. So Docker runtime on top of that read-only image, a temporary image, run this command and creates a folder called code and creates a new image, a temporary new image. And similarly, all the commands are executed. So these are called layers in Docker. So each layer is a delta of previous one. It just have this addition command. So Docker actually optimizes the way it builds the image. So suppose in a complex application, you have added one more command at the bottom or somewhere in the middle. So Docker will reuse the previously created temporary images and start new instructions only from the place where you have made change in Docker file. So this is how it uses and minimizes additional calls, additional space, or additional instructions to be carried out. And finally, the last command of any Docker file, a CMD. We will also learn about entry point later on, but a CMD which says, after doing all these instructions, run a container using this command. That is, this is the first command that should be run in a container. And this final command actually creates an image which can run, which is not a read only. It is a writable image, and that's how it will convert into a exe which runs a container. So you just have to understand that all these previous layers are cached and are temporary, will be used again if you don't change the instructions. But the last one, which actually triggers when you give docker run command, it will be creating an image which is final, and it is also writable, which runs. Okay, so this is the final image that we get. Now I hope that at least on a very high level basis you understand what is a docker. Now I want you to get your hand dirty and at least create a very basic image. And all the instructions to create an image are actually part of this link. If you can't access the link, just ask the track helper around you. They will help you to get through this image. You just have to read. It is just a single page, an official Docker document. You just have to read this, follow the step by step, and ensure that you go through. You are able to create your first image on a local machine. You can verify the end of this hands-on is when you can verify on your local machine that you run Docker images, and the image that you created, the name is appearing on your terminal. Now, how do you run and create that image? How do you create that image is actually given here. This is the final command, but all the setup that you have to do to run that command is given in this document. So let's take a hands-on break for 20 minutes and resume the next video. Thank you.